Here I am, and screen, and begin. Restart that to get the pen working. I want to get through these tonight because I want to do some differentiation tonight. Find the length of the side log x, round intermediate values to the nearest tenth. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. So I've already stated that I disagree with this. Rounding intermediate values is bad. You should only round your final value. So I will be off by potentially a few tenths, but it doesn't really matter so much. Okay, so in this case, we had to find the length x there, and we could use cosine rule and sine rule, but instead we're going to use right angle trigonometry. Okay, so there's our sort of intermediate value there, y, and that's opposite the angle 39, and 38 is adjacent to it, so we use the tangent function. And what that says is tan of 39 is y over 38, and thus y is 38 tan 39. So y is 38 tan 39. And now that you height, all divided by 2. Base times height, all divided by 2. So I thought I figured out a trick to get this calculator to work, because I thought that it wasn't actually the battery that ran out, but rather the connector on the inside. Well, if the calculator is not going to work, we'll have to contend with Wolfram Alpha, which will take a century to load. And when it finishes, it sort of loads up the page, and then it will continue loading. And then whatever you type in, it'll just delete it. And so you have to just wait for them to get up all their advertisements. Oh, look at that. They take you straight to an advertisement page. Hold on. Okay, so the base is 46 plus 46 over tan 70 degrees times tan 44 degrees. Closing that off, and that's the base, and then that must be multiplied by the height, which is 46 over tan 70. And then all of that must be divided by 2. And we compute, and we obtain probably an absurd number, 530.2. But anyhow, here we go. I hope there aren't too many like this. Okay, I really need that calculator to get going. Oh, now it's working. Okay. Okay, so here. Okay, so tan of 50 is 41 over h. So h is 41 over tan of 50. And once we have the hypotenuse, we can figure out this other part of the base, call it b prime. B prime, in this case, the right angle triangle on the right, we use tan again. So tan of 65 is B prime over H. So B prime is H times tan of 65, isn't it? Yeah. Okay, and once you have that, add the base parts together. So 41 plus 41 tan 65 over tan 50. Close that off. Now multiply by the height and stick 2 on the denominator. An absurdly huge figure. So I'm not believing any of these. So I'm going to actually have to check and see if I'm doing this right. The first bunch are all fine. They're all fine. And these here are actually, they're fine. That's surprising. Okay, so obtain the height. Recognize the special right triangle. It's the 30, 60, 90 right triangle. This is the longer leg. Yes, this is the longer leg. So that will correspond to the root 3 on the 1 root 3 2 special right triangle. So divide that by root 3 in order to get h. And now that you have h, you seek the other part of the base. So that involves the opposite and adjacent to this 52-degree angle right here. So tan of 52 is B prime over H. So B prime is H times tan of 52. So 29 tan 52 over root 3. And then sum the base parts together. Multiply by the height. Stick 2 in the denominator. And there's your answer. The area is around 422.2. Next up. All right, I presume that 70 corresponds to that, and that 32 corresponds to that tiny little bit that right there. So the height, tan of 70 is h over 32. So h is 32 times, beg your pardon. Tan of 70 is tan of 70 is h over 32. So h is 32 times tan of 70. And now that you have the height, you need to work out this part of the base. This is almost the 30, 60, 90 right triangle, but not quite. So to obtain that part of the base, we got the opposite, we got the adjacent involved. So it will be tan again. So tan 9 is the height over this part of the base. Okay, so that part of the base is h over tan of 29 degrees, and then you just do the usual. So 32 plus the height, which is 32 tan 70. Divide that by tan 29. There you've obtained the base. Multiply that by the height. And divide it by 2 while you're at it. All right, stop working. So I have to use Wolfram Alpha for this. Right, the base is 32 plus the height, which is 32 tan 70. And then that has to be divided by tan of 29. And once we've obtained the base, multiply that by the height, which is 32 tan 70, but divided by 2 while there. And hopefully it's going to work in degrees. Thank goodness for that. Right, so this is a very large number. There. Okay, here we have, now it's working again. So it selectively works. So here we have the special 30, 60, 90 right triangle. The hypotenuse is 20 instead of the usual 2. So that's scaled up by a factor of 10. So the height will be 10 root 3. And we don't have any other information about this thing. So let's see now. All right, so we'd want this part of the base, and we'd want this part of the base. So I should distinguish between them. We'll just call it AB for now. Don't care that it confuses with the base. So A in this particular case, let's see. That would be half the hypotenuse, so that would be 10. Now, as for B, well, we have 10 root 3 here, so it's going to involve the tangent function. So tan of 68 is B over tan root 3. So B is tan root 3 times 68. Tan root 3 times tan 68. So add them together, multiply by the height. Not going to chance it. 10 plus 10 times square root 3 times tan 68. That's the base, and the height is 10 root 3. And then all of that has to be divided by 2, so turn that 10 into a 5. And 457.9 appears to be the area, or so it seems. Just 3 more here. Here's the 30, 60, 90 right triangle again. The hypotenuse, instead of being 2, is 33. So to get this length right here, the length of the lesser leg, call that 33 over 2. And let's see. Well, we can obtain this missing angle here. It should be 48 degrees. Not sure how that's going to help, but anyway, we also need the height. So it'll be that 33 figure divided by 2, divided by 33, times it by 2. Wait, what am I doing? Oh, no. Root 3 over 2 times 33. That's the height. Now for this part of the base, well, it'll be tan of 48 is b over h, and so b is h times tan 48. And then the usual. So open brackets, 33 over 2 plus the height, times that by 33 over 2. Okay. But that has to be multiplied by tan of 48. And that's the full base, and then times that by the height and divided by 2. $33 over 4. Let's say that. 689.3. Penultimate one. Okay, so the standard area rule, which is half AB times sine of C, which works when you have two sides and the angle between them, cannot work in this case because we only have one side. However, we can use the sine rule to obtain a missing side if we like. So we'll just call this side B for the base. It's actually suitable in this case. So we know that B over sine, well, we can just accelerate it here. B is 37 sine 68 over sine 70. That's the base. And this other angle here, well, they sum to 138, and so this here is 42 degrees. And so we can use half times 37 times B times sine of 42 degrees. Try that. So we'll type in 0.5 times 37 times, and then we open up a pair of brackets and type in 37 times sine 68. Divide that by sine of 70. And finally times the whole lot by sine of 42. You obtain 451.9. Okay, similar story over here. We would like this missing side, so in this case we'll just call it A. And so we can say that sine of 45 times, 44 times sine of 45 degrees over sine of 66 degrees. That's how you get that missing side right there. And then the area is, well, we need to work out the missing angle as well. So we have 111. Take that from 180, and you have 69 degrees. So it's half times 44 times A times the sine of 69 degrees. So we're just going to type in 22, times that by, open a pair of brackets here, 44 sine 45 over sine 66, close those brackets, and times it by, sine of 69. And we get 699.5. Okay, now to check. Okay, good. All in agreement, considering the rounding situation. Okay, brilliant. Now comes rhombuses and kites. Okay, I'm not sure what on earth this is. Experiencing an error.